Okay, ladies and gentlemen, I think we should probably get underway in terms of our timing that we have for this session. I'm sure that we will have other people joining us as the session moves on, but we must move on in terms of time. Once again, before we start the session, we're about to ask you to vote on a number of questions. So I would ask you to take out your device, your smart device, whether it is a telephone or a tablet, and we will get ourselves ready to vote on the session that we're moving into in the next couple of moments. We're talking around urban connectivity, and just before I ask these questions, I have a quick public service announcement. If you happen to have picked up a bag from the back of the room, 2 rows from the back, and it happens to not be yours, perhaps you have picked it up by mistake, could you please put it to the registration desk, and they will get it to the rightful owner. It would be fabulous. Thank you very much for that. So let's move into the urban connectivity panel. And as we get into here, we're talking around elements that innovation requires vision and daring to think outside the box, and also requires commitment and collaboration. Our panel here on stage will present their views and experiences on the challenges and the opportunities regarding transport, mobility, and smart infrastructure. We asked our panel a number of questions, such as how will the future of urban connectivity look in low and middle income countries? What will the shift to EVs mean to infrastructure? And what new forms of mobility, fully integrated into mobility infrastructure of cities, such as autonomous driving, will attract funding? So we'll find out some of the answers to those questions. But right now, if you have your app ready, we'll ask you these questions. And the first of them is, in which year will the number of electrical vehicles sold globally outnumber the number of cars sold with conventional engines? And we'll put this on screen for you and see what your answer might be. Here we go. In which year will the number of electrical vehicles sold globally outnumber the number of cars sold with conventional fuel engines? It's always exciting to see what the results of these polls are. That's not a bad number, I have to say, coming from the results we have. Right, here we go. The results for the first poll are, okay, quite a split across there. We've got a very interesting mix. We do have a second question for you. I'll activate that one, move to our next poll. This is, do you believe the problem of urban congestion can be reduced or solved by opening up the third dimension vertically for urban transport using services like drones, autonomous air taxis, helicopters on demand, and such as that? So let's look at this. Answer the question for us, please. Do you believe the problem of urban congestion can be reduced or solved by opening up the third dimension? No? Yes? I have no idea. Significant amount of input coming through too. Great to see. Also, a big warm welcome to our worldwide audience joining us via the web. Great to have you here too. Right. Answers here. Okay, they can be reduced. A good half of our people here believe this. 14% still have no idea. We'll see if we can clarify things for you as we go. Activate that. On to the next question. Do you believe electrical driven two-wheelers such as e-bike or pedelec or three-wheelers will be mainstream mobility solutions in urban centres for transport of passengers and goods? Again, no, yes, or I have no idea. Fire away with your answer right now. Do you believe electrical driven two-wheelers, e-bikes, pedelecs or three-wheelers will be mainstream mobility solutions? For our audience across the world as well, I hope that potentially you're voting on these as well. Last few seconds. There we go. Results for that. Very clear split across there, with a no and a yes. Let's see what our panel might have to say around these as we head through into the panel now. So, ladies and gents, we have that's not the correct slide, so we'll move forward. Jump out of that. Yes. Excellent. So we have a fabulous panel up here on stage, ladies and gents, and ably looking after us in fine style is our FIDIC Executive Committee member and Treasurer. In 2018, he took over the position of Vice Chairman of the Board of AHT Group AG, a German consulting engineering firm based in Essen. And I'm talking, of course, about our moderator for the session, Dr. Bernd Cordes.
Good afternoon, everybody. It's a pleasure to see so many of you directly after lunch here. I'm not going to make a phone call. This is just my second memory. I will not make a speech. That's what we have the experts for. I'm not the expert. I'm just trying to keep everything together. So the way we will run this session is we will have 4 presentations, directly one after the other. With the intention to have a little bit of time for discussion. We will start off with Loïc Chapon, CEO of Société Bertrand. He will give us an overview on new ways of connecting urban and peri-urban areas. Thereafter, we will make a big jump to Africa with Lynn Pretorius, Director of the consulting company Innovative Transport Solutions. She will address topics related to smart mobility in Africa. Then from Africa, we'll move over to the United States. And James Raleigh, National Transport Director of CDM Smith, will talk about track platooning. Those of you which do not know what is track platooning will hear it in a minute. And then we'll finish off with a presentation from Paul Rogers, who is a senior partner of Büro Happold Engineering. He is located here in Berlin, and he will talk about 3 tiers of urban mobility using the example of our host city, Berlin, which makes a lot of sense. So thank you very much, and I would say immediately we'll go into the sessions. Thank you.
Ladies and gentlemen, thank you for your participation. And I would like to present me. In the beginning, I'm responsible to develop the automotive market industry for Bertrand AG. It's a German company. And I'm a member of the Syntec Engineering Union. And I would like to expose you my overview about the connectivity and urban connectivity. The development of connecting urban and peri-urban areas is creating a mobility evolution and impose a global vision. Public authorities, engineering companies, infrastructure and vehicle manufacturers, industrialists, system operators, and all service providers are involved and engaged in the development of innovation necessary for this change. The 360 singularity of engineering companies allows them to objectively address the diversity of subjects integrating complete mobility solutions, whether there be infrastructures, equipment, vehicles, or associated digital services. This contribution of experiences therefore benefits in terms of efficiency all the players in mobility. Themes to explore and develop. Some examples. connected infrastructure to facilitate drivers' behavior and enhance road safety. Territorial service platforms, ticketing, passenger information, etc., and the mass to make the viable and sustainable aggregation of mobility services for a complete and optimized offer of solutions for citizens. Electromobility to reduce GIGs. Autonomous shuttles to improve last-mile service and optimize transport networks. Self-driving vehicles to enhance road safety. Carpooling to reduce car traffic by increasing the fill weight of passenger cars, therefore reducing noise and road accidents. Dynamic on-demand transport for a more cohesive mobility and to serve citizens in sparsely populated areas. Multimodal poles for an efficient organization of the aggregation of different physical mobility offers. The management of parking control system to improve the rotation of the vehicles, facilitate short-term parking and free up spaces occupied by immobilized vehicles for too long. One of the challenges of connected mobility is sharing the data needed to develop solutions, but them into operation and market solutions and services. The opening of data to all stakeholders within the framework set by the qualified public authorities is essential for the development of new mobility services. However, in order to secure their use, it will be necessary to grant all the data ownership right to the mobility organizing authorities products in connection with the operation and maintenance of the transport networks and services. Mobility, which they would have eventually conceded. We will move from an offer of means to a range of mobility services that will offer diversified solutions according to expectations, habits, and objectives of users. This will lead to the decompartmentalization of the offers of public and private players. And now I would like to present you one example for the technology way to develop by my company 3 years ago.
Safety and comfort functions have become an essential part of modern vehicles. But how can driver assistance systems be optimally adapted to the needs of the driver and to the surrounding conditions in order to make driving easier? Analyses of both the driver and the environment are two key components on the way towards fully automated individual mobility. The functions developed by Bertrand within the Be Competent project make this idea best suited for our roads. How do connected assistance systems optimize safety in a vehicle? They start by analyzing the driver. This allows them to create a tailor-made driver profile based on key attributes such as sporty driving, safety awareness, and energy efficiency. The second part of the system adaptation to the driver involves environmental analysis. For example, the system analyzes route information, the level of traffic and weather data. The sensor data recorded in the vehicle and information on the driving style are sent to the back end via the telecommunications network or via wireless LAN. The back end is a server for the analysis, distribution and refinement of data. Before the data reach the back end, they are already compressed in the vehicle and are refined on the ECU by classification and decision algorithms. This process optimizes data communication and safety. After the analysis has taken place, recommendations for action are sent to the vehicle in order to adapt the safety and comfort aspects of the driver assistance systems to the driver. Until now, a detailed analysis of the driver has always been performed while he or she was driving, and this process had to be repeated before every journey. In the new system, however, the back end performs a comprehensive driver analysis by means of long-term learning. In other words, the data are not lost when the engine is switched off, but remain assigned to the vehicle, allowing the driver's behavior to be evaluated over a long period in correlation with other environmental conditions. By analyzing the environmental conditions, the vehicle is able to recognize dangers before it reaches a particular part of the route ahead. For example, if dangerous weather conditions are imminent, the vehicle uses the weather data to warn the driver by a message on the display, and then adapts the system to the new conditions, for example by reducing the vehicle's speed, increasing the distance from the vehicle in front, or switching on the headlights. Road surface analysis makes it possible for entire vehicle fleets to learn from the experience of a single vehicle. For example, if a vehicle drives over a pothole, it will automatically send a message to the back end, which classifies the section of the road accordingly and communicates the information to the following vehicles. In this way, damage to the vehicle caused by poor road surfaces can in future be avoided.
Für die Entwicklung von autonomen und hochautomatisierten Fahren müssen verschiedene Disziplinen zusammenwachsen. Aus dem Fahrzeugbereich wie Elektronik oder Powertrain, aus dem IT-Bereich, Backend-Infrastrukturen, Cloud Solutions, aus der Mathematik, Machine Learning, Algorithmenentwicklung. Daher stellen wir interdisziplinäre Teams zusammen, um künftige Anforderungen beim Kunden gerecht zu werden.
For error analyses in vehicle development, Be Competent can detect faults in the vehicle and report them to the back end via wireless LAN and GSM. If data logger problems occur because a connection to the vehicle bus has been interrupted, the driver receives a warning message from the back end on the display. The driver is advised to park the vehicle at the next opportunity and to inspect the system. If the fault is resolved, the warning signal on the vehicle display goes out and is reset in the back end. Normal driving can then continue. Online diagnosis helps the driver to correctly assess error messages on the display. The message data are sent to the back end. The back end analyzes the vehicle's fault memory and advises whether it is possible to continue driving or, if necessary, gives the location of the nearest repair workshop. In order to reduce wear in the vehicle, the driver is given advice on the type of driving style that can help to extend the lifetime of wearing parts. At the same time, the data stored by ECUs are recorded as the vehicle's history. This information can be communicated to the vehicle manufacturers for use in the development of wearing parts.
Für immer höher automatisierte Fahrfunktionen ist eine zuverlässige und genaue Fahrzeugpositionierung unerlässlich. Deswegen arbeiten wir zusammen mit dem Fraunhofer IES an einer GPS-basierten Lösung, die weder die Mobilfunkverbindung am Fahrzeug belastet, noch zusätzliche Karten benötigt. Stattdessen geben wir die Korrekturdaten per DAB-Radio ans Fahrzeug und ermöglichen es so, dass das Fahrzeug die Kommunikation mit anderen Verkehrsteilnehmern ungestört aufrechterhalten kann, Daten ins Backend schicken kann und trotzdem an einer Kreuzung anhalten kann, ohne dass der Fahrer die Bremse betätigen muss.
Be Competent makes it possible to precisely locate the vehicle. Instead of relying on the GPS signal alone, the receiver makes use of correction data to improve positioning. This data is transmitted by the DAB digital radio system. For example, the vehicle can be safely brought to a standstill at a predefined stop line at a road junction without manual braking. Do you have any questions about connected assistance systems, or do you require support in the field of function development? Then please contact us. We look forward to helping you. Bertrand, your technology specialist.
Yes, and this a small innovation of the connected vehicle. And since this demonstrator, we are developing a new generation of autonomous cars with electric, energy, connected, and environmentally friendly vehicle. And also, to move an autonomous vehicle in an urban environment, we need to make the vehicle data interact with its environment and data coming from infrastructures, other vehicles, and external information systems. To secure and optimize the movement of vehicles while providing the most user-friendly service, the solutions must integrate the wearable data set and be able to exploit them. The huge technology evolutions impose the new ways of cooperation between all branches of the infrastructures, industry, and IoT. We must develop global solutions. We have plenty of opportunities in front of us if we seize the new megatrends. Infrastructure players must bring innovations and get support from private and public stakeholders and develop the new network with other partners. We can imagine in a few years using intelligent means of transport that integrate artificial intelligence technologies. The first objective would be the adaptation of the offer to the habits and each user, but also the optimization and improvement of autonomous systems to make the solutions more efficient. Thank you very much. And now,
Good afternoon, everyone. I am from a firm in South Africa called Innovative Transport Solutions, a firm specializing in transport solutions across the board: roads, traffic engineering, public transport, road safety, pedestrian and cycle planning and design, intelligent transport systems. And especially within the field of public transport, we've been involved recently almost in all bus rapid transit projects in South Africa and within the southern SADC community, Southern African Development Community, especially in the operations and technology side. And we've recently also started to get involved in tunnel management and freeway management, all about technology-driven solutions and management tools to the field of transport. Now, like the rest of the urban centers in the world, Africa's major cities are going to be confronted with rapid urbanization and has to confront all the challenges associated with it. Major changes are afoot, and authorities, public transport operators alike are all poised to respond to all the challenges and opportunities that might come about. Current talk includes mobility as a service, or in short, MaaS, smart cities. We've heard about autonomous vehicles, and Loic, thanks for laying the groundwork for that, quite a detailed presentation on it, and artificial intelligence. But what does this all mean for Africa and perhaps for other major urban centers in the developing parts of the world? And my position and viewpoint today is about considering Africa's transport realities, our urban realities, and wondering about smart mobility in Africa in the context of modern-day public transport trends. So first, just let's look at these new trends in public transport. We hear about digitization, connectivity, and it's all about how to connect with our passengers. Mobility as a service, it's about mass transit systems connected and supported by other mobility options. There's talk about on-demand, flexible and shared transport, operations being introduced by new players, using technology and innovation as a base to connect with passengers and to improve services to our customers. And there's talk about new cost structures as well, as we're expecting fuel costs to be reducing through the use of electric and hybrid vehicles. And all of these concepts, generally using technology, cell phone applications to communicate with customers, tracking vehicles, and the monitoring of operations. Now, at a very basic level, all of this require very sophisticated operator, public transport authority relationships and contracts. It's operating in a very mature institutional and governance environment. And through it all, we need the use of cell technologies with a strong ICT backbone. And across these urban centers, typically we find networks of routes and services, stations and stops, all allowing for high levels of connectivity across cities. Now, Africa in general does not have this overall level of maturity in mass urban transport provision. Africa is going to be confronted with rapid urbanization, as I've stated earlier. Data presented already in 2010 indicated that about 8 African cities can expect a 50% and more increase by the year 25 in population. Some major centers being Lagos, Dar es Salaam, Nairobi, Kinshasa. Africa is urbanizing later and at a lower income level than any other developing region, which means policymakers can learn from the successes and failures of other countries. At a conference recently held in Africa, one of the presenters stated that Africa is clearly infrastructure hungry. But it is generally challenging to quantify this lack of infrastructure investment and maintenance in Africa that we're experiencing. Some of the figures that are quoted, about just less than $100 billion is needed annually over the next decade to overhaul sub-Saharan African infrastructure. About 2/3 of that is probably needed for new infrastructure and 1/3 for maintenance. But Africa is at the start of a 20 to 30-year infrastructure development boom. In contrast, some World Bank reports in 2017 stated that African cities are closed for business and they are also out of service. And this is due to the low levels of connectivity and mobility due to the lack of transport and other supporting infrastructure, the high cost of urban living, high cost of commuting, wages, staff costs, food, building costs, as well as the limited or lack of basic service delivery in some cities. And when we look at the transport modal split in Africa, very interesting trends. Data collected in 2012 at the University of Cape Town clearly shows the significant role that walking, cycling, and the informal public transport market plays within African cities. More interesting, it shows the very, very low share of the formal bus sector. And studies have also been showing that this share in the formal bus sector has been declining. BRT implementation has taken place in some African cities since 2008, starting off with Lagos in 2008, and the more recent startup of a BRT phase in Port Elizabeth in South Africa as recent as 2018. In South Africa, the cost of BRT infrastructure is really making the system difficult to sustain. So having considered all of this, how should Africa respond? What role can technology play? We are advocating a very simple back-to-basics approach when we engage with our clients across African cities. It must get the basic right, but it must also learn from other cities with sound urban transport systems already at a level of maturity and sophistication that enables technology and communication systems to be introduced. So a very back-to-basics approach: avoid, shift, improve, enable. And through all of this, looking at opportunities for installing some form of technology so that we can collect data, enable us to do better decision-making. We must strive, plan, and implement sound urban planning principles in managing the cities. And this will just add to the efficiencies required for the sustainability of megacities in the future. And it goes without saying that addressing the informal public transport sector in African cities, this is where a real change can come about. A starting point potentially is to develop incentives to organize informal operators and pursue contracted services where required, train these operators, as the informal sector definitely has a significant role to play. One role is to provide feeder services to mass transit routes. Informal operators in Africa already provide some form of a mass service, mobility as a service. They are everywhere for customers and almost offer a door-to-door service. But imagine if they are organized and have better communication with their customers. Can this potentially be an app-based model using the appetite for cell phone and smartphone usage in Africa? And another opportunity for this informal sector is a feeder role to these mass transit corridors. With mass transit, we have to talk about dedicated public transport infrastructure. Specific emphasis, though, on the quality and capacity of roads, providing public transport priority at intersections, and the role of bus lanes and busways. But when introducing these form of bus operations and this form of dedicated infrastructure, it should be clearly understood whether bus rapid transit is required or versus a very simple commuter public transport system. Communication can go a long way, but only a scheduled and reliable public transport system can be communicated, and this is where cell technology can definitely play a role. ICT, hardware and software will be required, but without a sound base and the enabling environment and capacity, it can become a white elephant. Planners, engineers and policymakers must understand the ecosystem of technology, the maturity of the operations and the government environment in African cities. At a basic level, developing a concept of operations for automated public transport systems, identifying the range of technology required, and developing a progressive rollout plan without necessarily starting out with just building in technology without really understanding the requirements and the consequences thereof. African cities must definitely focus on clean fuels in their public transport systems. The use of electric and hybrid buses will completely disrupt the cost structure of transit systems. But walking and cycling has a significant share in African cities, and improving conditions and road safety for pedestrians will go a long way in improving connectivity across cities and access to public transport systems. And I've seen a few slides now today and yesterday showing the role of autonomous vehicles pedestrians and bicycles using the roads without any form of control. But what is not clear to me is really the unpredictability of human behavior, that of pedestrians, cyclists and children within the road environment. Cycling has a huge potential in Africa, and it accounts for a very low modal transport share at the moment. But the real fears in public consultation is around road safety and security. And obviously, women cycling has significant cultural implications in some parts of Africa, even within the urban centers. So in conclusion, innovation and disruption in the way we do things is significantly influencing the way transit systems are being designed. Mobility as a service is a key requirement of modern systems, but it's based on the application of technology at many levels. My message is perhaps not the most popular and the most attractive at a conference like this. But for Africa, the message is real. We should just not be throwing technology at public transport systems in Africa. We cannot just pursue technology at the expense of employment creation. And we cannot pursue it because we are still struggling with the basics. But we must definitely identify those opportunities for innovation and technology that can work for us. And I want to emphasize that Africa has different challenges, has developing economies, is urbanizing later and at a lower income level than many other developed regions. And it means that policymakers can and must learn from the successes and failures of other regions. Done right, simple but effective urban transport systems can significantly raise both the productivity and living standards within Africa's megacities of the future. And in our pursuit in being smart, sometimes being smart just means getting the basics right. Thank you.
Thank you. Good afternoon, and thank you for the opportunity to speak here today. I'm Jim Riley. I work for a firm called CDM Smith, and I live in Cleveland, Ohio. First time to Berlin, so really enjoying the mobility and actually looking forward to hearing our next speaker talk about the mobility here in Berlin. Today I want to talk about the freight element of urban connectivity. First, I want to talk about some freight challenges that we have in the United States. Then we're going to talk a little bit about some of the strategies and the solutions that are being enacted in the United States. And then lastly, I'm going to specifically talk about a concept of operations for what we call driver-assisted truck platooning for a project that I'm working on in the city of Columbus, Ohio. Okay. What did I do? That's not my next slide. What should I do to click forward? Okay, just use that? Okay. Right and left. All right. Sorry about that. Freight moved over 7 million miles of highways, waterways, local roads, navigable waterways, and pipelines. This is in 2015. Just some stats to lay the groundwork for the freight movement that we're talking about in the United States. That's over 55 million tons that was moved during this time period, and that's a value of over $49 billion. Freight accounts for 8% of the United States gross domestic product, and it has helped create approximately 3.1 million jobs, while it also supports another 44 million jobs annually. Funding for transportation in the United States has really been insufficient and inadequate. It's based on the gas tax formula with declining revenues. It has not been good, but in the freight world, we see the outlook is improving. In 2016, the last Transportation Act gave almost $11 billion specifically for freight grants and freight programs. So there's some positive movement in that direction. when we look at the future and we look to 2040, what does it look like? I mean, the population is growing, online shopping is growing, people are working remotely, lots of trends that are really affecting the freight community. The predictions that we're going to be, the U.S. economy will double in size by 2040, and 34% growth in freight movement as well. Interesting fact that by that period of time, it's estimated that 90% of the population in the United States is going to be living in urban areas. Today, it's about 85%. There's continual issues and challenges that we have in having the workforce expertise and training available to meet the demands. There's newer trends like cybersecurity risks and just the application of new technology. And also the inadequate planning and modeling tools. I mean, how do you begin to plan and model your urban areas for connected and autonomous vehicles when we don't really know the adoption rate and the impact it's going to have on driver choices and freight movements? And of course, it goes without saying that the growth in the overall freight puts an increased pressure on the entire system. You know, the map on the left shows the congestion hotspots, if you will, today, and the map on the right shows the 2040 projection with the increased, conditions. And it's estimated that 30,000 miles of our busiest highways in the United States are going to be congested, and that's going to cost drivers at least $27 billion. Big numbers, big problem. So the U.S. established a national committee to look at programs and strategies to drive mobility and economic solutions. What could be done? And really looked in three areas, looked at funding and identified a number of grant programs at the national level. Again, I talked about $11 billion has been focused toward this, and that's good news. A lot of regulatory strategies have been investigated, including really just trying to streamline the project process and particularly the environmental clearance process, and also the encouragement of public-private partnerships, especially in the freight world here when we're dealing with private companies and just talking about the mobility of their goods. There should be a significant interest on their part to be participating in improving the infrastructure. But that'll be a common theme that I mentioned several times, is really getting the funding to build these improvements is obviously the biggest hurdle. So, from the infrastructure strategy side, and that's where I'm going to talk a little bit about emerging technologies and some things that we're looking at CDM Smith, a little bit about dedicated truck lanes as well. So there are very few truck lanes in the United States today. I mean, they're a great solution separating the trucks from the regular traffic from a safety and to reduce congestion standpoint. But again, the major challenge is really finding the funding. You can see here on the map, we actually have 2 truck-only lanes in California today. There's one being built in the Atlanta area, and you can see there's several others that are being planned, particularly in Texas and some in the Midwest there. Does anybody know where Ohio is? You can see it up on the map. That's what I'm going to be talking about. That's where I live. It's up by the Great Lakes, right where you see 90 and 80 is where I live in Cleveland, Ohio. Just down the road from us is a city called Columbus, Ohio, and the U.S. government has gotten pretty serious in the last 12 months about moving forward with the study of connected and autonomous vehicles. They've been doing a lot of work for the last 10 years, but over the last 12 months, they created a couple of programs. One is called Connected Vehicle Program, and the other is the Smart Cities Challenge, and that's where they asked cities to submit applications for this one-time grant to look at the application of data and technology to manage the assets and the infrastructure of the city. And Columbus was awarded that grant. CDM Smith helped them prepare that, and we're working with a host of other consultants on a number of projects in the Columbus area looking at, again, mobility as a service, and particularly I'm going to talk about the freight project. One other thing the U.S. government has been working on, and particularly the Federal Highway Administration, has been the development of what's called FIDIC, or the Freight Advanced Traveler Information System. It's ultimately a bundle of 3 transformative applications to just address freight mobility, from the just-in-time and parking operations to optimizing drayage operations, and also providing dynamic route guidance as well. We've tested it in Los Angeles, Fort Lauderdale, and Dallas, and it's basically a platform that is integrating existing corridor data and information with real-time information on parking and congestion, and transferring that to the driver in the vehicle to make decisions. So this is going to become our national standard in this regard. So here's kind of the nut of what I wanted to present to you here today, the Columbus Driver-Assisted Truck Platooning. This is ultimately the concept of operations that we have in place. As you can see on the top, it shows loaded trucks in the center, and that would be, okay, so we're working with 3 different companies in Columbus. One of them is the Limited, Victoria's Secret brands, ironically. They have cargo planes come into Rickenbacker Airport, and that plane needs about 10 to 12 trucks to take this shipment to a distribution center. And they have about 100 a month. And so we're working directly with that company saying, okay, how do we just facilitate the movement of your trucks from Rickenbacker Airport to your distribution center? So they travel on city streets for a few miles, then they get on an interstate highway for about 20 miles, then they get off and get back on the city streets for another couple of miles. And so while they're on the city streets, we're going to work with signal prioritization for the truck vehicles, very similar to bus rapid transit prioritization. And then when they're on the freeway, they will work in a platoon environment where the driver requests to platoon with the other truck. And there's also going to be some level of a network coordination center. City of Columbus has a traffic management system right now, and that is going to be working in coordinating with the drivers. But we're also looking at the option of truck companies and in the distribution community and maybe providing their own operation center. We really don't know which way this is going right now. So the expected benefits are certainly to reduce fuel consumption and emissions. In fact, tests have shown already at 55 miles per hour and at a 50-foot headway between trucks that the second vehicle saves 10%. 10% on fuel consumption and reduced emissions, while the front vehicle can save 4%. Again, apply that over many, many thousands of miles of trucks moving, and the benefits could be significant. There's also improved benefits, certainly on the logistical and the operation side. When that Victoria's Secret truck knows that there's 2 trucks coming and they're going to get there on time, that they're going to have the resources there to load and unload, and they could plan their business operations around it much more efficiently. So the current status of the project for the Columbus project right now is the platooning technology is being acquired right now as we speak and being put into the vehicles of the couple of companies we're working on. And we're still working out the deployment and the performance measure details, specifically the operating procedures for the platoons, the scope of the network control, like I said, whether that's done by the Columbus Management Center or a third party, and really what we're going to measure during this. We anticipate having, this will be up and operational in 2019. So the key players in this whole truck platooning concept is the truck driver, because they need to request the platooning of the other driver, and drivers need to respond with the onboard information. Certainly the logistics and the operations staff of the trucking companies, so they can coordinate the daily truck movement. The city and the state, the traffic agencies and the planners, definitely in monitoring and watching how this can improve the system, and then of course being able to encourage other programs to implement more platooning across their city or their state. And then also, like I said, the last component, a network operating center, whether it's within the city or the trucking company or even run by a third party. Some more considerations that are still out there that we need to be addressing and considering, and one is certainly legislation. When two trucks are following each other so closely along the freeway, our patrol officers like to pull them over and say they're not operating in a safe manner. There's actual a headway distance that's expected within the law that would have to be changed to allow trucks to be platooning along these corridors. Obviously, the operational considerations of what lane is the best to be operating in. How do you deal with potential vehicles cutting in? How do you mark these vehicles so that the rest of us know that it is a truck platoon in process? Is it a flashing light? Is it a sign on the side of the vehicle? These kind of things are very important as we move toward implementation from the law enforcement side and the public awareness side. So just in conclusion, truck platooning has been proven to be safe or to save fuel and reduce emissions. That's the ultimate benefit. Again, applied at a national macroscopic scale, the benefits can be just significant if it's widely used and integrated. And state and local agencies need to be involved in both facilitating the platooning, allowing it, and assuring its safe use on the highways. So I thank you for the time here today, and I'll turn it over to our next speaker. Thank you.
So good afternoon, everybody. My name is Paul Rogers. I'm an engineer. I'd like to talk about Berlin. I'd like to thank FIDIC for inviting me to speak today. And in some respects, I'd like to think I'm a participant to this conference, but also I feel very much a host, as Berlin has been my home for the last 25 years. So it's been a place that I've lived and from which I've practiced engineering. And so, if I may, if my German colleagues would allow me, I'll give an Englishman's perspective of the mobility of Berlin. And I'd like to give that perspective on looking at it from three tiers, from three scales. And I'd like briefly to talk about transportation that really could be considered on a national stroke city scale. I'd like to talk about what I would call mobility, which is very much about how do we integrate cities around nodes. And I'll come on to what nodes could be, but they could be campuses, commercial centres, transportation hubs. And then I'd like to go down into a topology of one of those hubs and just talk about what that means in terms of the built environment, in terms of integrating modern mobility solutions at that scale of the city. I'm going to come and, or I guess, as you visit to Berlin, you've probably moved around the city, and I guess your impression is that it's been quite an easy city to move around, offering quite a lot of quality. And I'll come back briefly and just talk about the area between Potsdamer Platz and Hauptbahnhof, because you might have used the public networks over the weekend. But I'd like to go back 100 years just briefly, because I think Berlin has excellent precedent in investing into public transportation to support urban development and quality urban development. This is a not particularly distinguished image of a square just a couple of kilometers away from here. But down in the right-hand side, you see two circles, which are the entrance to the underground network. And that is that square in 1907. So it actually created incredible precedent. They built the underground networks and without any urban development. And if you see the sign at the back of that square, they're actually selling sites. So they're actually leveraging the value of public mobility services to build economic value into their land values. But that precedent sort of repeated itself. The Berlin Wall came down in 1989, unification in 1990. And there was an opportunity for Berlin. There was a very short window, in fact, to invest into its key infrastructure, key transportation infrastructure. And you might have visited Potsdamer Platz and Hauptbahnhof to the north of this picture. And through the early 90s, and it was sort of an Olympian effort, you compare that to the airport now, but what the planners did, city planners and engineers did in the early 90s, they had a very small window to integrate an awful lot of public infrastructure transport before the commercial developers came and built very livable cities on these areas. So the blue line that you see is the long distance and city trains, and that is the underground roadways that go under the Tiergarten. And just to get a feeling for that, this probably was somewhere in the region of 1996, 97. So you get a bit of a one-off opportunity. So if you're planning any serious TOD type activity, you've got to think quite serious about how you integrate this public infrastructure. And I can't point, but you can see some on the left, the roadway line for the tunnel, and on the right of that, you start to see the excavations for the railway tunnels. And there you can see this fight for space between commercial towers, which are going up just as quickly as underground railway lines are trying to be constructed. So it is a really serious effort to coordinate public and private initiatives in sort of reknitting cities back together. This is looking at the other way, so we're sitting over the top of Hauptbahnhof, looking south towards Potsdamer Platz. And again, you can see the scale of the excavations. Berlin is built on sand. It's got a very high water table. You can see they had to relocate the river for a while they built the tunnels under the river. And today, again, you can see that railway lines approximately on that lineage. And there you see the roadways. And today you experience, and maybe you've enjoyed that at the weekend, and if not, you should take a walk. It's only a 15, 20-minute walk down through the Tiergarten. And a lot of this infrastructure is actually invisible. It's underground. And when it was being built, I didn't really grasp the importance of it. But being an engineer looking back, you suddenly realize, how invisible infrastructure, underground infrastructure, is so key to a quality urban environment. And the area just south of the Hauptbahnhof is now 40 hectares of prime commercial development that was just waiting to be developed for 2 generations. So this longevity of infrastructure and the timing of development through a city, it didn't all have to happen at once, and it's built great public space opportunity. So if we just look back 25 years, so when that infrastructure was being planned, what are the 3 big things that have changed from a mobility perspective, specific to Germany perhaps? Energy is a big theme. There's been an Energiewende in Germany, intermodal mobility networks. I'll come on to that. And I don't think it needs me to talk more about information technology communication at this conference. I think we've heard so much about that. But there is an Energiewende in Germany. There's a desire to turn off nuclear power stations. There's a desire to run down fossil fuel demands. And if you see that progress, just looking at that green line here, from going back 25 years, something like a third of Germany's energy supply is coming from renewable technologies. And if you're going to run an emission-free, sustainable mobility strategy in our major cities, then you need to build that. And I think Germany's on a pretty good way. Germany had a love affair with the car. It still does, frankly. Dieselgate is a very good example of that. But I would say there's definitely a generational change in acceptance or disacceptance of the car. People want access to mobility. They want access to shared mobility platforms. And you can see their car use going down. But equally, although I'm going to come on and talk about mobility service offerings, the mobility ranking of Berlin is surprisingly quite low in its take-up on shared bikes, shared scooters, shared cars. So the upward potential is just enormous. And finally, as I say, it doesn't need me to reinforce this message anymore. Life has changed. Most of us probably didn't have a mobile phone when that key infrastructure was being planned. Today we carry around computers, and you can see just on your iPhone the scale of processing technology. It's just remarkable. But really, this isn't about technology and data. So what does that mean? How do we integrate the city, and how do we create the hubs that we can actually access usable, affordable mobility? We entered a project just around 2011, actually kicked off in 2012. It was government financed with lots of partners, generally speaking from a technology and product service offering perspective. I think we were the only partner that was looking at the built environment, looking at how do we integrate infrastructure and accessibility into our cities that actually we can accommodate a take-up on shared mobility platforms. So it's a 3-year project. The success of that, you could actually buy from German Railways, from Deutsche Bahn, you could buy a mobility card that allowed you to access cars, and it isn't just about cars, but electronic bikes, electronic scooters. You could use your underground. So we created a seamless platform of access to mobility, so you could ditch your car. All of that accessed over your iPhone. If you go back 6 or 7 years, this was quite revolutionary and supported through urban smart grid technology. So looking at neighborhoods in terms of renewable energy strategies to help fuel that and top up some of the large-scale renewable production that was going on across Germany. So we looked at that from a number of perspectives. We looked at that from a social economic perspective. Where are people employed? Where is the economy? In terms of location of these services. We looked at that from live car sharing data. At that time, very low quantum of data. But what were people using, and what was the uptake at that time? Of course, it would look completely different today. And then modeling that across what's already there in terms of a public transportation network. And suddenly you can start to overlay that, and you can start to prioritize the sort of infrastructure you need, where you need it. You can start to think about who's going to finance and operate that infrastructure. And then we tried to take that, again, going back 5 or 6 years, and these pictures look a bit old actually now. It looks like we're actually exceeding these aspirations. But looking at 3 case studies, this was a Zuidkreuz, a transportation hub just a few kilometers south of here. So looking at adaptations that would need to take place by around 2020 to start accommodating accessibility to the mobility offerings that we're looking at. Taking that further on into 2030. So looking at ways of decluttering the city with private cars effectively by making shared mobility platforms affordable and accessible. Similarly, into existing urban neighborhoods, because this is the problem we have. We need to retrofit our cities, but knowing technology and trends in usage are going to change. So how can we declutter? How can we invest in modest infrastructure? How can we make that accessible? And how can we develop that over a period of time, that the built environment? And actually, I think it's slightly missing in the last days, that puts people back at the center of the cities they live in terms of habitable cities. And finally, looking at industrial campuses, and the same thing, just looking at how you can declutter those over a period of time. So going on into the third scale now, so, the sort of nodes that I was talking about were the transportation hubs, were university campuses, industrial sites. But of course, new neighborhoods. Berlin has a housing problem. It's having to develop an awful lot of new housing at the moment. So this is a master plan we're looking at the moment, and as a consulting engineer, we're looking at all the usual things that you would look at in terms of energy, water resource, mobility, logistics, waste, and ICT. But things are changing, because although we would have looked at that in terms of clusters of those disciplines, and we would have certainly have looked at integrating that from a technical engineering integration perspective, we're now looking at doing that in terms of, obviously, the energy cluster talks to the mobility cluster, talks to the ICT cluster. So we're having to look at digital platforms to support that. Spoken a lot about that in the last few days. More interestingly, of course, we're looking at operational platforms. So we're having to integrate expertise into our consultancy teams to actually start knitting this together, because we're bringing different service providers, different ownership models. Is it the developer that's owning some in this? Is it the community itself that's owning this? So looking at ways that the community can actually partake in its ownership of its own communities. And finally, of course, there has to be an interface into the built environment that we're actually designing. And this development was 4,500 residential units, so it's got a population of about 7,000 people. None of the residential buildings have basements on this site. And it's the objective of the developer initially to look at a car-free environment, but we're looking at sort of a low car intensity use. So what does that mean? We're looking at reducing modal split from something like 30% down to about 20% for car use. So we look at other measures to try and reduce density of cars. So if I was only looking at the mobility cluster of this development, we're starting to look at a different type of infrastructure in the traditional sense. So we're looking at mobility hubs. We're looking at car sharing and infrastructure around sharing of mobility. We're looking at shuttles to get people around their neighborhood to connect them to where the mobility hubs are, a biking infrastructure, ride sharing, that sort of thing. And we're looking at that as a set of hard measures of what a new infrastructure language might look like. Looking at soft measures around, how would you communicate that and engage the communities into that. And alongside, obviously, the digital platforms and the organization to actually lead it. On this particular development, we're currently looking at 2 mobility hubs. I call them mobility hubs, but in reality, they are public service locations. So your Amazon will drop off there. You can have clinics and doctors and all sorts of public services at them. So we're looking at specifying how that might work in a cascaded hub environment. We've done a bit of work around journey times. If your car's not under your house, and there's a presumption in life that it normally is, how are you going to get to your mobility hub? Are you going to buy into this concept? So we're looking at transportation within sites. We put autonomous vehicles on there. There's no reason why it needs to be autonomous. It could be somebody driving those vehicles, but we need to look at a cascaded layer of mobility within the city. So just to close, quick look at what I would call the 3 levels of mobility. Having one is not enough. You've got to look at all 3, and you've got to try and integrate them. So a quick impulse. Thank you very much.
I think we have 4 very different presentations, and I think it gives us all a grasp of what the problem is. It is going to find the appropriate solution for a specific situation, and they are very different from region to region. But there is one element, and one which is going through all these presentations, the word platform. And I have one question related to that that's burning on my mind since yesterday morning. Now I have the opportunity to ask the question to all 4 of you, and maybe each of you gives a very quick answer to this question. And in the meantime, you have time to think about your questions, and within the next 4 minutes, you can then start asking your questions. We're talking a lot about platforms. On local level, regional, national level, who is going to be the owner or the operator of the platform and the data in the platform? Maybe we'll start from that side. A very quick response. Who is going to run the platform? Who is owning it? Who is using, has the benefit of the data? Any ideas?
It's not easy to answer on this question because it's real problem. It's to secure the data and how we manage the cyber security and how we manage the use of the information, because we need the general information of the cities to provide some services, for example, and after to exploit the vehicles in the city. Okay. And we must do controls and check the use of utilization.
Thank you. Lynn, any ideas?
Yes, in my view, the data must definitely be owned by the public sector. Mm-hmm. You need to have very, very strong oversight in your public sector, your authorities. Having said that, you could have challenges when it comes to the analysis and the management of the data. And potentially there's the role for the private sector, but it will surely be based on a very, very strong service level agreement, because privacy and the ethics of using data, personal data, is going to be a challenge.
Okay, thank you.
The state and the government definitely needs to own the data, at least in the U.S. That's the way it's going to be. But the only way to build that platform is to be involving the private sector and creating some kind of revenue model that incentivizes the private sector to be able to use the data. And there'll obviously be some terms and agreements around all of that. But it really, I see it being developed as a public-private partnership in the U.S.
I mean, if the platform is only data, and the B-Mobility project proved that, sharing that is really difficult. So leveraging shared mobility is challenged by sharing that. But I would encourage us to think of the platform as being far more than just the data platform. We need very many more components that can come from private development and public development to build a complete offering that's covered.
Good. Thank you. I learned a lot in the last 3 minutes. Thank you. So, questions from the floor.
Yeah, we have one over there. And I'll take one from the front.
To Senior VP CDM Smith, I'm Jaffrey from India. It has always been a constant source of wonderment that here you're talking about your eastern portion of US getting totally clogged by the roads getting clogged and truck platooning. But I fail to understand why aren't the railways? There's absolutely no stress on the railways being put. Had it happened in India or China, these countries would have failed if we depended so much on railways. So is there no thought process on developing US railways? we can help you from India and China.
I
Guarantee.
think that's a question for you.
Talking about rail, right?
Yeah.
Railways, there's absolutely
When
no
we're
stress.
talking about rail systems, why doesn't it appear in the article?
Your roads are getting clogged up.
Why aren't I? I'm sorry, because I'm having a hard time understanding the question. But did you say why aren't I talking about rail systems?
No, that's what I want to find out. It's a source of constant wonderment for me that in US, there's absolutely no stress on the railways. You're
Yes.
talking about your roads getting clogged up. A couple of decades back, one could understand that the automotive lobby was very strong and they ensured that the railways don't come up.
Thank you very much. I think we understand the question. Right.
Yes, yes. No, the U.S. is a very unique animal, obviously compared to Europe. I mean, the railways are not used to the extent that they should be used. We've become, I mean, as soon as the interstate system was built in the 50s and 60s, with Eisenhower, the trucking companies and commercialized, they just started using those arteries to their commercial benefit. And it's more convenient and it's more flexible, and they can move goods, you know, to a lot more locations than just the several fixed railroads. So it's how it's developed in the United States, and it's become a huge problem.
Okay, next question.
Over here, Bernd.
My question is actually the same with the gentleman. It's about railway, because now a freight truck is already 70% of the trucks. Well, actually, economical-wise, fuel economy is actually on the rail is quite good, 400 ton miles per gallon, basically, versus the railway. But I think you have answered the question. Thank you.
Okay, good.
My name is Balaji Ogunsanya from Association for Consulting Engineering in Nigeria. Lynn, my comments are to you. What, in your view, is the most suitable form of transportation for Africa? Bearing in mind that fossil fuels are going extinct, don't you think we should look at a combination of water and trains? Because these buses need a lot of maintenance and so forth. There are problems, local problems in Africa. Thank you.
I couldn't agree with you more. With Africa's current population levels and the demand for travel within the urban centres, definitely these kind of mass transit systems should be rail-based, because that is really where you get the kind of capacities that you need during peak hour operations. The reality is in Africa that it is very expensive to build these rail infrastructure that is required. And in the last few years, we've learned a lot from our South American neighbors about the introduction of BRT. It's a whole lot cheaper per kilometer to implement, but there are challenges. There are definitely challenges when it comes to operational efficiencies when you get this level of public transport congestion that is now being experienced in some of the Latin American cities, where there's definitely a move over from your high-capacity BRT lines to start introducing rail, because you can get more increased capacities on it. And obviously, if watercourses is an obvious solution for transit corridors within some Africa cities, within an integrated transport plan, those African solutions should be, or transport solutions should definitely be implemented to be able to move people across the cities. I attempted to very just broadly look at some of the BRT implementation that is happening across Africa, but surely it is not the only way of moving people within Africa's future megacities.
Just for those that are maybe not transportation engineers like myself, BRT stands for Bus Rapid Transit. Next question.
Over this side again. Thank you, Ben.
Thank you. My name is Charles Akindami from Lagos, Nigeria. I'm directing my question to Lynn as well. Firstly, it's a very good presentation, and then bringing Africa to FIDIC, because we hardly see some presentation from Africa FIDIC, but your own was quite incisive. In terms of bridging the gap from what we've been hearing throughout today in terms of mobility, and looking at the basic transportation systems we have there, I'm getting worried that there's no way Africa can catch up based on our way of transportation system and what is going on now. Now, maybe Africa should be looking at some different type of models in transportation. Maybe flying. Maybe you can see women being flying tomorrow. I don't know. So, because the way we are going, we are about almost 100 years behind what is going on now. But from what you've shown in terms of BRT that is going on in South Africa and also in Nigeria, a lot of Africans still want to own cars because they feel it's a status symbol, it's comfortable and so forth. What are you doing in South Africa to motivate them using mass transit system? And also the waterways, how are you using that in a way in order to be able to reduce cars, buses on the road? If you can just try and let us know.
So maybe just to start with the last part of the question, how are we using waterways as a form of transport? In no way at all in South African cities is waterways being considered. Most of our coastal cities, we don't have that opportunities. We've got rivers in inland, but it's not used at all, and it's not really viewed as a form of transportation for mass transport in many ways. What are we doing to encourage people to use public transport across these cities? It is a challenge, and you are quite right, especially within African cities. The purchase of a car, it is still an aspirational purchase. It's got to do with your social status in life and your upward social mobility, and it is a challenge. We are seeing across our cities, we are still seeing increased car ownership. It's progressively increasing, and we really don't, in the foreseeable future, I don't see a change in that. Having said that, there isn't more space at all to build new roads to accommodate these increased cars in the South African cities. And this is really where South Africa is right now, with a significant amount of infrastructure and funding in public transport infrastructure in South African cities. A significant focus on upgrading our rail network, increasing capacities, a significant focus on pedestrianisation, especially at local neighbourhood level, improving opportunities for cycling, making cycling affordable. We are looking at e-hailing, how to bring it into the formal transport sector. And in South Africa, as in many other African cities, the role of the minibus taxi, that is our informal public transport sector. We are looking at ways to incentivize those operators to come into the formal business market. Because that is really, if you want to improve public transport operations within South Africa, you have to address that. It is a significant sector when it comes to employment creation, as well as the associated jobs created around the public transport system. So you cannot look in a social context, in an economic context, you cannot just look at public transport as purely a technical solution. You have to consider the economic implications when you start intervening in such a significant component of our economy.
Thank you, Lynn. Please.
Hi, everyone. Thank you for some wonderful presentations. My name is Declan Nolan. I'm Irish, but based in China at the moment. I think my question is more directed towards Mr. Rogers, but I'd like to hear any other feedback from the group. What I'd like to know is how the interaction between public leaders and the private industry in providing different transport solutions. So, for example, where you've got disruptors like Uber or maybe Mobike or Ofo coming in and just dropping a solution onto the market and then it disrupting everything that happens. How do you constrain it? How do you encourage it? How do you integrate it? What is that relationship? How does it look like? How do you put it into the plans that you guys are putting forward?
I might be wrong, but I think Uber's banned in Berlin. I don't think it's encouraged at all.
Globally. Sorry, not just Berlin, but I mean just a globally apply that solution to any city.
But come to that discussion we had about the platform. I think there's so many dimensions to that platform, so I wouldn't see those sort of disruptors as being a destabilizer into that market. I think it would be additive. I mean, the reality is the uptake or the provision that we can uptake is always going to be challenged over the next 20 years. So some disruption would be very good, of course, because it would actually to fill the gaps. And I think part of the challenge could be scaling. We very much talked about major urban developments here. A lot of people don't live in necessarily live in the major cities. But I would see disruption as actually being pretty good in this space at the moment. You know, I think there's more than enough market share to respond to.
Maybe I can add a little bit on that. I think one of the differences between Germany and a few other European countries and major other parts of the world is that we have quite strong regulations and authorities. And when Uber, for example, tried to enter Germany, they more or less were not successful. Not because their business model wasn't good, it was because the administrations, together with taxi authorities and others, were able to hinder them getting into the market.
Could I also just add to that from a South African perspective? We've also had a significant amount of disruption in our meter taxi services provided, or the cabs. And over the last few years, months in fact, we've seen that tension escalating into violence between your formal regulated meter taxi industry and the Uber drivers, to the extent now where we've actually just introduced in our national legislation that e-hailing services must be regulated. So you do find now that your operator Uber, the drivers and the operator, they have to apply for operating licenses within metropolitan areas, along with the sedan taxi operators.
Any more questions? We have one or maybe time for one more question. Okay, no more question? There is one over there.
Yes, please.
So this is going to be the last question. Thank you very much.
Thank you. My name is Sam Mambo from Kenya. As I sit here, I think I got a bit confused now. One, we are talking of smart cities. When I listen to the speakers, particularly from this part of the world, I hear you are closing down the coal mines. I hear you are dismantling the nuclear plants. I hear very soon you are not going to be using diesel. In my country, Kenya, we are very happy, or the government is very happy to have found coal, so they want to start exploiting that. We are talking of investing in nuclear energy because our power supply is not reliable. Now, I don't know what direction we should take, to have these smart cities. Thank you.
Let me make a closing remark. I said earlier that different parts of the world have different situations. So I think we are all aware that there are certain countries that's moving out of nuclear. And we are now realizing how expensive nuclear power is. It's very expensive. Not to build, but to operate, to dismantle. And there's not a single nuclear power plant that didn't overrun 200, 300% in cost in the last years. On the other side, there are some countries that are moving into it. Maybe they do it better than we did in the past. And coal, climate change is a reality. That's the driver in Europe and in some other parts of the world. We just see another maybe Hurricane 5 category coming to the eastern coast of the US. This is, of course, nothing to do with climate change. It's just by accident. There is no answer to the question, except that different parts of the world have different ways of looking at it. Thank you very much for being with us this afternoon and for asking many questions. Thank you very much to all of you preparing fantastic presentations. Thanks a lot. Have a good time.
Thank you very much indeed, of course, to Dr. Bernd Cordes as well, as our panel, Loic Chapon, Lynn Pretorius, James P. Riley and Paul Rogers. Ladies and gents, just a quick note, we have 2 further sessions today before we reach the conclusion. We would love to see you back before we close the day and be heading off to the local colour night. Enjoy your afternoon tea. We will see you in half an hour, back ready to go, 3:30 p.m. Thank you.